Welcome to another edition of Bürkert Bytes. Today we're going to talk about connectivity. They say that Ethernet is the backbone of this whole digitalisation. Well, I have to say that it's the M12 that is the workhorse, because you'll notice M12s popping up on almost every single device that we have in the field and also the blocks that we're using to connect them. So today we're going to talk about all of the different types of M12s and, most importantly, how to have a successful installation. Firstly, let's start with the different types of M12s that you may find in the field. Most common one is the A-coded, which is used for all standard I/O, both hardwired as well as IO-Link, EDIP, ASSIE, the whole lot, is an A-coded M12 connector. You'll also see B-coded, which is a purple cable used specifically for Profibus. And you'll see D-coded. Now D-coded, normally the cables are male-male, and these are used for industrial Ethernet. So generally you find them Profinet certified, but you'll also be able to use them on Ethernet IP, Modbus TCP, and other industrial Ethernet networks. It generally means that they're shielded and made to a standard that's ready for industrial Ethernet. There is another version which is also looks fairly similar, that is X-coded. Now that's generally used when you need higher than Cat5e and generally on things like gigabit backbones that are still on copper cable. So you will see that X-coded out there as well. Another one that's fairly new to the market is the L-coded. Now this is a power cable that can take up to 16 amps. So it's generally used for connecting power to the different blocks and things in the field. There's a number of different types, as you can see, right angle and straight, and it depends on your block and how they are all keyed as to what works, and also on the particular sensors, whether the straight or right angle will sit out at a strange angle, or you need to use one or the other. The last one is an S-coded. That's another power distribution module. Looks fairly similar to the L-coded. However, it's generally used, it's a 3-pin and generally used only for AC power connection. As an example, you'll see on this block here, we have A-coded for our main connections, and we have D-coded for our Ethernet connections, and L-coded for our power. So you can't put any of the wrong ones in the wrong areas, so that's why we have the different codings for the different types. What's also important with these is also choosing the cable. So you have to make sure that the cable is fit for purpose. In other words, if it's on robotics and you use a stiff cable, then you'll find your cable's not going to last very long. So you're going to have to choose a cable that's actually perfect for that high flex application. More importantly, things like UV stabilization because of mounting out in direct weather and sunlight, etc., as well as things like the size and shape of it as well. So always get UV stabilized, always meet the site standards as far as the IEC or site standard colorings, etc., for things like Ethernet. And yeah, special word on the L-coded power. Most of the L-coded power you see in the market is just 1.5 square mil. Now, when you're running 24 volts, especially over I/O platforms, when you're connecting lots and lots of I/O, 1.5 square mil we've found doesn't always cut it. So Bürkert has a specific 2.5 square mil which we like to standardize on where possible. Just to give you an example, if you're to run just 6 amps across 20 meters, then the 1.5 square mil will drop about 4 whole volts. So your actual 24 volt system will fail. It will go outside specification. With the 2.5 mil square mil unit, then you're still well and truly within specification with that 6 amps. Considering this cable and these connectors are capable of taking 16 amps, that's good to know that you've got enough oomph in the cable and that you can run it over longer distances. The other things that we need to consider now are how we install these cables, because it's easy to say we've got the cables, they're great, they're IP65, 67, and many of them even 69K. So they're more than weatherproof and able to handle almost any environment. Now that said, I'll put it to you that there's many people out there who install them incorrectly. So what we're going to talk about today is the correct way to actually install these cables. Okay, For starters, when you're running cables in the field during installation, construction sites are messy, they're wet, they're dirty. Quite often we see blocks getting mounted in the field with open ports, as well as cables hanging beside them, not yet terminated or connected, also with open ports and terminations, and there's water and sprays and things like that. Anytime you put any of these devices in the field, make sure you cap them off, so that any of the environment, the dust and whatever. It only takes 24 hours for a wasp to build a nest inside a plug, and then of course you're trying to dig it out and you mess it up, or someone drags a piece of pipe and they smash off the thread or something like that. So do what you can to protect before the installation. That's number one. Secondly, try wherever possible to use molded cables. These molded cables are made in very, very precise methods, and they all come pre-tested so that you know when you connect these, they are meeting the IP67 or 69K and that they do work. Sometimes if we use field wireables, and I'm not saying that we can't use them, but sometimes you have to, you do find that there's manual intervention, there's chances for cable termination problems, etc., and air gaps in there that can fill up with water and things like that. So wherever can, use the molded cables. Okay, next one is the most important take home I want today, is that connect the cables with the right amount of force. Generally what we find is people take a cable, they take a block and they connect it via hand. Now, quick word on this. Always be patient and take your time. Don't cross thread one of these, because if you cross thread a block, you might find that, you're not going to be able to recover from that. So wriggle it in, make sure you can push it safe. You should be able to wind it most of the way with your hands. If you have to use a spanner in that early stages, one would suggest you've got a problem already. Now, the issue is we hand tighten and we say that's done. So that's the way most people do their M12s, because they call them quick connects. We can do them with our hands. The problem is you've not engaged the O-ring that's inside. Other people will turn around and use a spanner on there, and what they'll do is they'll engage that O-ring for sure, but they'll actually crush it, and it may seal this time, but may never seal again. What we suggest is to use a torque driver. So just to give you an idea, I've tightened that by hand, and now if I put that on there, I'm getting another good 3/4 of a turn, taking that to the recommended 1 Newton meter. Now I say 1 Newton meter, this is the maximum you should tighten it to, and we recommend that for metal to metal type connectors. If you're talking a metal to plastic connector or plastic to plastic connector, we would say maybe bring that down to 0.6. But even 0.6 or 1 Newton meter is still stronger than hand. I will never be able to undo that by hand. And in an industrial site, that's a good thing. So we know now to undo it, we have to undo it like that. Yeah, these little torque drivers, they are available from Bürkert, and they work with both M12 and M8 connectors. This one here is available from 0.6 to 1 Newton meter, and is specifically designed to go on most of the cables that you've got in the field. You will actually hear it click when it reaches up the right torque. And you can of course adjust it down to 0.6 Newton meters if you're doing a plastic to plastic connection, as we spoke. One of the things that's crucially important is if you don't have one of these, then what we often tell our customers to do is don't use a spanner, but make sure you use something as simple and as small as a tiny little connector with only about that much capability. So anything more than that and more force than you can apply with one finger, that is also about 1 Newton meter. So if you've got that supplied with the block, then just use that to do up your connectors. However, we do recommend these. They are available from Bürkert or other vendors as well. So it's really important, and that goes the same for your I/O, your Ethernet and your L-coded connectors. Always do them up to the right tension and do them up to 1 Newton meter where possible. Okay, when connecting devices in the field, whether it be at the block or at the cable, we always recommend running a loop so that you've got a little bit of spare just in case you need to change that device down the field. It gives you some flexibility to move and go from there. Last but not least, make sure that you complete the labels and label your cables, all of your cables, where they're coming from, where they're going to, etc. If this is going to a sensor, a temperature transmitter, then we'll say TT1107 or whatever. And then on your device, you should also complete your label. Now, not on every network, but some networks, as an example, IO-Link, that port is assigned to the sensor in the field. If you put it back into the next port and you do the wrong one, then it's not going to work. And in the middle of the night, that could cause you a lot of downtime because you say it's plugged in, it's powered, the lights are on, but the PLC doesn't see it. So always label your cable, label its destination, so you know exactly how to do it. Just as you would with any good electrical installation, we need to do it with digital installations as well. Okay, finally, they're often mounted in really arduous environments where there's moisture, there's mechanical stress, etc. So wherever possible, keep away from mechanical stress. Anything that's actually pulling on the connectors or any cable that's installed that has a force trying to bend the connector back, try and make sure that everything is connected in a nice and easy way. And also ensure that you may install a block. And as an example, we can install this block in the field. As I said, it's right up to IP69K. But if you've got water or chemicals or cleaning fluids absolutely dripping on it all day, or one of the big killers can be direct sunlight in some countries as well. So always try and shield it where possible, whether you build just a little hat over it or something like that to protect it from any ingress like that. It also might be a site where you're dragging around big hoses or cables. Make sure you have protection so that things aren't getting dragged across and all the cables being ripped out of their sockets. Lastly, if you are in a really wet environment where you know there's a lot of moisture or steam or things like that, then it doesn't hurt to put a little bit of grease. Now we recommend the Molykote 4 or to Dow Corning silicone grease. Do not use hard silicons because they will eventually just dry and yeah, they crack and you end up with wicking going through them. So a silicone grease will actually fill any air cavities, and you can use that. You can use that right through from ASSI cables right through to connectors. You don't use it a lot. You're just lubricating and moistening the O-ring a little bit and making sure that there's no area for liquid ingress, because you find if it's a proper electrical compound silicone grease, it will support any ingress of water. So I hope today that's given you a bit of a heads up on the correct way to install these devices. And I do hope that yeah, you have successful installations in the future. Thank you.